What we do in social science, whether it's psychology or sociology or political science or even public health, what we do is when we work with inferential statistics, we have a process of hypothesis testing. We use this process so that we can all agree on how to treat the probability. Write this down. Right. Now, in order to do this, we got to sort of have a bucket on the floor process. Right? We all have to agree that we're going to do the same thing. And in doing the same thing, that gives it validity because we all are doing the same thing, and we can compare across studies. We can have a conversation. It's like a common language. When I go to a professional conference and listen to other people present their research, they don't need to say, well, the first thing that I did was develop a hypothesis. No, because we're all doing it. We're all doing the same thing. The first thing I did in the morning was get out of bed. Then I went to the bathroom, did bathroom things, left the bathroom, put on clothes, starting with my inner garments first and then working my way towards my outer garments. Right? We don't have to say that. You say, I got up and went to school. Right? So by having a routine process, we don't have to say, well, the first thing that I did was develop a research hypothesis. The next step was develop a null hypothesis. I'll get to this stuff in a minute. Then I selected the appropriate test. Then I defined my decision rule, which really isn't anything you do because we have conventional wisdom. Then I calculated the probability. So I've already taught you step 5. I got to go back and teach you guys step 1 and 2 and 3 and 4. And then once you learn about what those things are, then step 6, you make a decision. And then step 7, discuss the conclusion. And you tell everybody why you're right. So what we're going to do is we're going to sort of walk our way through what these things are, so that I hope you understand what it is we're doing when we're creating these z-scores. Let's start with a hypothesis. Now there's 2 types of hypotheses. One is a research hypothesis, and the other one is what we call a null hypothesis. Somebody give me another term for the word null. Not false, void, or 0. All right? Void, 0, 0 in the idea of nothingness. Void, I like that one, as in not true, not valid. Okay. The null hypothesis and our research hypothesis are usually opposites. So sometimes it's easier to think of the null hypothesis first. And here's a very simple one. There are all sorts of fields that do this. Are men and women different? Yes? You sure? Now you're sitting in between 2 women. Are you sure you want to say men and women are different? So according to Ryan, men are smarter than women. But you just told me they were different.
I could be dumber.
You could be, but you told me that they're different. And so men are smarter than women. Or dumber? Perhaps. He's like, I'm in trouble now. Okay. Are men better drivers than women? Yeah, statistically, yeah, guys, let's not go down that road, okay? Because you don't really know. All right. If men are statistically better drivers than women, why are car insurance rates lower for women? I actually have a smart-ass answer to that, but I want to see if anybody knows. No. No. I mean, these all may be true, but they're not the thing that you need to read my mind about.
Are people more likely to press charge or like file a lawsuit against men for drivers?
I don't know. Again, that's not the thing in my head. What's in my head? Men are more likely to drive than women. And because the frequency in which they drive is greater, they are, by definition, more likely to get into a car accident. Professor Wood, why is it that men are more likely to drive than women? Because when a man and a woman ride in the car at the same time, who's driving? Usually the man. Usually. Okay? Anyways. So it's a frequency thing, not a skill thing. Also, car insurance rates are based upon experience. And women don't get as much experience driving a car because men don't let them. All right.
Would that like be the opposite? Like, wouldn't car insurance for females be more expensive since they don't drive as much and don't get as much experience?
Again, you got to put all of these things together. But women also may drive slower, and they might drive calmer, and they might drive safer cars, right? So all you guys came up with these differences between men and women. They might, cancel each other out, work together. That's the end of the course kind of stuff. We need to stick to the very simple questions at the beginning of the course. Are men and women different? Well, if that's your research hypothesis, right? If that's your idea, that women are more likely to support Hillary Clinton because she's a woman and because of the representational theory that people select their representatives based upon their oneness with them, whether it's gender or race or location, geography, common background, right? Whatever that is, your null hypothesis is usually that there is no relationship between that thing you think that makes us different. So whether it's gender or race or hair color or prior military service or fitness, whatever you say is a causing factor in a difference, the null hypothesis is always that there is no difference. No difference, no effect. When we write this down, we will always state the null hypothesis as hypothesis 0 for null. No differences. No difference. That's the null hypothesis. Your research hypothesis is commonly referred to as an alternative hypothesis. What you believe to be the relationship. So again, with gender, let's say that men are smarter than women. What is one way in which we can measure smartness with air quotes? IQ tests. Okay? So how would we, as a researcher, figure out if men are smarter than women? We're going to give them an IQ test. Are we going to test every man and every woman? No. So we're going to do a survey or a test. We're going to collect some data, and we're going to have a sample mean for men and a sample mean for women. Now, if men are smarter than women, what should the difference between the mu of male minus the mu of females be? Should be positive. If women are smarter than men, right? That's an alternative hypothesis. What should the difference be? Negative.
The second one, you said females are smarter than men?
Yep.
Wouldn't that be positive?
Oh, I'm sorry. Yeah, the way that I wrote it. Thank you for that. This would be positive, this would be negative. Okay. So, if we do this and we end up with z-scores that are negative, that would indicate that the female sample mean was larger than the male sample mean. And if we end up with positive z-scores, that would indicate that the male sample mean was larger than the female sample mean. Yeah? We all cool with that? So that's why it's important to understand that sometimes which side of the mean you're on is important. This is known, yes, it's an alternative hypothesis, but this is also known as a directional hypothesis. If you're saying greater than or less than, it might be important to understand that when you're thinking about the curve and what that curve represents. So this is step 1 and step 2. Step 1 and 2 is identifying the hypotheses. And you'll notice that we're doing it relative to our statistics, right? Our sample mean. The null hypothesis is typically that the difference is equal to 0. The alternative hypothesis is that there is a difference, and we should see that in our sample mean. Now, when we did the dice thing, the difference between when you rolled the dice, mean of students, was 9, and when I rolled the dice was 7.6. Now, if we think about this framework, if I'm telling you that faculty are better at rolling dice than students, my alternative hypothesis would be hypothesis 1 equals mean of faculty minus mean of students does not equal 0. In that case, we're not really talking about, well, we could say we're talking about directional, but what we're most concerned about is the difference. And whether it's positive or negative will tell us if that difference, in terms of being better or not. When we develop a hypothesis, we have to make sure that what we're doing is what we would call falsifiable. And I have 2 examples to go through here, and we'll see if which one is the better one of understanding what is falsifiable or not. So let's start with Jason. We know that all humans are mortal. Yes? I believe Jason is a human. I spray Jason with Raid. Jason dies. Does this prove that Jason is a human? Jake, you're shaking your head no. Why?
Because what's spraying with Ray have to do with anything?
He dies.
Well, he could-
And humans die.
he could have died from something else.
Okay, so Joey says lots of other things die. What could Jason have been? A cockroach. Okay, so we haven't necessarily proven that Jason is human. Let's start again. Jason is shredded, set on fire, and sprayed with Raid. Jason lives. Jason's not human, right?
It could happen to you. It's unlikely, but it's possible.
Okay. Next class, we're going to talk about the 4 outcomes when we evaluate hypotheses. Okay? See you next time. We'll figure out what Jason is.